Alright, we're here at gotomath.com. Click on the calculus button. Let's go down to numerical integration. I believe we're doing this one here, 1.2. Okay. Let's scroll down. It says use the trapezoid rule for approximating the definite integral with n equals 4, and this is the number of subintervals. So let's go ahead and write this down, 0 to 3 x cubed dx. If you don't have it written down, I'll give you another chance. Okay, so we have, whoa, let's use black. So we're going from, what are we going from, 0 to 3? Is that right? Going from 0 to 3, yeah. 0 to 3. X cubed dx. So you should know how to find the exact value of this. Now, let me just go ahead and write this out up here. So our f of x is our x cubed, and we're on the interval between 0 and 3, on the interval between 0 and 3. Okay, so this is going to be the last time, actually, that I do this. Okay, so we're just concerned about between 0 and 3, so I'm not going to draw out the whole graph, but anyway, it goes something like this. And it's something like, kind of looks like a parabola, right? A little steeper, though. And we're between 0 and, let's say, 3. We'll say 3 is over here somewhere. Okay? And I guess there's something else I failed to mention. N is equal to 4. Now, what n is the number of subintervals. N's the number of subintervals, so we would break this up into 4 separate pieces. See, so let's say, see if I can do this. 1, 3. Okay, let's see here. 1, 2, and then we need one more, right? So let's try it. Let's do something like that. There's 4 subintervals. 1, 2, 3, and then this would be 4 right here. Okay. So we're finding the area. What we're doing is we're going to break this up into 4 trapezoids. And we're going to find the area. We're going to find the area of each trapezoid. Now I know this one here is fishy because the height of it is 0, but don't worry about that. Anyway, so the trapezoid, do we remember what the formula for a trapezoid? Trapezoid takes on a couple different shapes really. But this side here is straight across. So the formula for a trapezoid, now this A and this B are completely different from, let's say, if this were A and that was B, okay, completely different. And this is H. So to remember how to find the area of a trapezoid, the area of this trapezoid, we'll just say A is equal to, we add both of these sides together, divide by 2. What that actually means is we're finding the average value, yeah, remember doing that, times H. Okay, so this is the actual formula right here for finding the area of the trapezoid. So if we found the area of this trapezoid, then the area of this trapezoid, the area of this trapezoid, and the area of this trapezoid, added all the areas together, well, that would be finding the area under the curve using the trapezoidal rule, really. And we could look at this as finding the area under the curve, even though we can actually do this more generally where we actually have some negative values over here and it still works out. But anyway, okay, so it's known as the trapezoidal rule. So to find the actual height here of this side and the actual height of this side right here, what we'd end up doing is we would take, for example, this would be our 0 right here. We'd start at 0, and then to find the first trapezoid, how far over do we need to go? That's the question. No, that's not the number 1. That's just an increment there, sorry. But how far over do we need to go? That's the question. That would be our H right here. Okay. And so this is how this works out. I'm going to go ahead and let's go back to black. Okay. Um, First off, we're going to need to know what delta x is. Now, delta x is going to be this distance right here, and each one of these are all equal. Okay. So delta x is b minus a over the number of subintervals. So we would cut this up into 4 pieces. So delta x is equal to, b is going to be 3 minus 0, right? So this is our a, this is our b. Now remember, this a and that b are completely different, but that's usually in a lot of formulas they use that. So that's the reason I used that. Okay, so this a and b has not got anything to do with these upper limits and lower limits here. Divided by n is 4, so that's pretty easy. We get 3/4. So delta x is 3/4. Now the question is, how far over do I need to go to get to this point here? Well, what we're going to be using for that is x of, for example, 0 is equal to 0. Okay, that's where we're starting. We're starting at 0. Plus delta x, which is 3/4. And this will let be our I, but our I is going to be 0 because we're not going over. So this right here, this is like if we had the letter I right here. Okay. And then the next one, x of 1 is equal to 0 plus 3/4 and 1. So that would be the first one over. So as you can see, this number here is going to end up being 3/4 or 0.75. And then we got x of 2, and that's going to be equaling 0 plus 3/4. Remember, that's our delta x, and we're going over how many delta x's? 2 of them. And so that ends up simplifying down to 9/4. Well, I guess it doesn't actually simplify down to, but and then we have x of 3, and that's 0 plus 3/4 times 3 is equal to, wait a minute, that should be 6/4 there. I guess I got ahead of myself, which actually reduces down to 3/2. Wasn't paying attention. 3/2 or 1.5. So this one here is going to be 9/4 here. All right. And then we've got one more to do. So this is going to be our x of 4, and this is going to be equal to 0 plus 3/4 times 4, and that is 3. So you can see here one of our endpoints is, I should write 0 here, is 0, and then the other endpoint is, our lower bound is 0 and upper bound is 3, as you can see. And then we go over 3/4, then 3/2, 9/4, and then finally to 3. So this would be 0. This one here would be 3/4. This x value is 3/2, 9/4, and then 3. Okay? All right, so we got that taken care of. And now what we want to do is go ahead and find the area of each one of these trapezoids. Okay? So for the first trapezoid, we'll just call this a of 1. So we got h. Okay, h. We got h, right? H is each one of these guys here. Okay. And so now what we're going to do is, okay, so we got to find this distance, and then this distance, and then divide it by 2. So you see that would be this right here. And I meant h is actually delta x there. That would be this distance here, which stays the same. Okay, so this is what we need to find. So to find this distance, we would say f of x of 0 plus f of x of 1. And then we divide that by 2. and then multiply that by h, and h is going to be the same on all of them, so that's going to end up being 3/4, yeah. So we'll just write 3/4 out here. Okay. All right. So what do we got here? Well, this just is this is just 0, right? 0 cubed. X of naught is 0, as we can see here, cubed, plus, and then f of x1, so we're plugging x1 in, which is actually 3/4. All right, 3/4, so this would be 3/4 cubed. Divide it by 2 times, and then of course h right here, and h is going to be 3/4 on all of them. So you see that? Okay, and then we have area 2. This would be the area of this trapezoid. So this is going to be f of x of 1 plus f of x of 2 divided by 2 times that by 3/4, right? So you notice we have an f of x1 up here and f of x of 1 because this side is now being shared with this trapezoid, right? The first trapezoid, the same side is being shared with this trapezoid here. I don't know. Anyway, all right, so now we end up with 3/4 for f of x1 cubed. Well, you missed out on that. I had a huge cough there. And now we do 3/2 cubed. Divide that by 2 times that by 3/4. All right, so I'll let you figure out what these guys are. Now we got the third trapezoid, f of x2 plus f of x3, right, divide that by 2 times. Now, of course, we know a little algebra. We can simplify all this down. For example, we can factor out a 2, we can factor out this 3/4, and we can also do some other stuff, and I may mention that in the next video. So let's go work on through this. So we have 3/2 cubed plus, and then x of 3 is 9/4 cubed divided by 2. Yeah, because this is all redundant, right? So we can actually shorten this down quite a bit. F of x3 plus f of x4, divide that by 2 times 3/4 is equal to, so we have 9/4 cubed plus, and then x of 4 is 3, right? That was our last one. 3 cubed over 2 times 3/4. Okay, so let's write down the sum here. So we sum up A1 plus A2 plus A3. What did I do that for? I did that earlier. Something. A3 plus A4, which is equal to. So now when you do the arithmetic here, you should come up with, on the first one, 81 over 512 plus, and then the next one you should have 729 over 512. I guess we need to move the screen a little bit. Plus, and then A3, I got 2835 over 512. And then A4, I got 7371. Now you notice we're using exact values here. You'll want to use exact values until you get to the final answer. And I don't mention anything about rounding in this. I'm not exactly sure why, but anyway. Okay, so we get to that point, and I'm trying to remember. I'd actually done this. So let's just do this. 81 plus 729 plus 2835 plus 7371. I just added all those together and then divide by 512. Okay, and so I end up getting 1377, which is the exact value. 1377 over, what is it? 64, I guess. And what do we get on the decimal representation? Whoa, we get some big number. 21.515625. Okay. Anyway, let's go back to and see. Of course, I already hit the answer. I wanted to make sure I got all that right before I did this problem or made a video of it. 5-1. Just making sure though. Okay. All right. So that's how you do using the trapezoidal rule. Okay. And of course, we could have. That's kind of the exact value there, but we could have, run to two decimal places, whatever. Anyway, we'll have to break open our chemistry book and look at the rules on significant figures to really kind of get it a little accurate. All right, so there you go. You can come on over, practice that. I don't think I'm going to go into all those details. We're going to shorten this problem down in the next, I think in this section here, section 2 or whatever you want to call it. All right, so there you go. Come on over to gotomath.com, check it out. For some reason, electricity went off here. Don't know. Maybe we're under a terrorist attack. I don't know. Anyway, look at the storm. All right, I'll talk to you later. Bye.